Hi everyone. Today we will be talking about a development framework called Polar. So Polar is a development framework for developing smart contracts on secret network. So first you can do is, let's say we do a command called Polar. So it will list you the version and the global options you have and the available tasks you have. So first thing we'll be doing is creating a boilerplate for our project. So the project is basically a repository that contains all your smart contracts and the peripheral files for them. So for that we can simply do Polar in it and whatever name you want to name it. Let's say we want to name it hello world. Okay, so here it has created a directory called hello world inside our current directory. So if we go into this, we'll see that we have a directory called contracts which has the data related to our Rust contracts. In the source directory you'll see you have four Rust files: contract.rs, lib.rs, message.rs, state.rs. You can learn about like how you can write the contract logic in Rust using some guides from Secret Network. In this one, like we'll first compile these contracts into a WASM file, and we'll also generate the JSON schema for them. So moving on, you will see that there's a polar.config.js file. So this JS file is a configuration file for the Polar. So whenever we create a repository for a project, Polar only take configs like such as accounts or what's the network configuration. Suppose you want to specify that okay, use this network as a test net, or use this network as my default network, or these are my accounts that you should use to sign the transaction or to deploy a contract. Those all go in this JS file. Next you have this directory called scripts. So scripts contains user scripts for interacting with the contract, which I'll explain in the later part of the video. And test contains all the test scripts that you'll write that will test all the interactions with the contract. So the next step you need to do is, once you have created the boilerplate, is to let's first have a look at the Polar config file. So this is the sample Polar config file. This is the one you will get when you will first time do the Polar init. So first you have the array of the accounts. Each account should have a name, address, and mnemonic, and your account should go in there, and you should not use these ones because these ones are provided in every Polar init. So these accounts are available to everyone, so you should not use these accounts in the mainnet, and definitely should not send any coins to these. Next you will see that you will have the network configurations. You'll see that we have three networks: default, development, and testnet. If you look at the testnet network, you have the endpoint, chain ID, trust node, and keyring backend. You can specify all these details, and you'll see that accounts is provided in this line for the testnet. So this value accounts corresponds to the array we saw above. And if you look at so now let's compile our contracts. So for that you can simply write Polar compile. Also, one thing to note here is that when you do a Polar compile, it calls the Rust compiler, which compiles your Rust files. So obviously it needs to have, your system needs to have the Rust compiler installed. If you don't have the Rust environment installed, please refer to the GitHub repository of Polar. There you'll have the instruction on how you can install them manually or using a command. So you need to make sure that your rust-up command is working and you have the nightly tool chain installed also. Okay, so at the end you'll see that it has created the artifact slash schema directory and artifact slash contracts directory. So if you'll see that we have a new directory called artifacts here, and if you have a look at what's inside it, you'll see that you have two directories. One is contracts, which has your WASM file for your contract. Since it only has one contract called sample project, it is created sample project.wasm file. And next you'll see you have a schema directory. Schema directory has schema for your sample project, which are listed below. You have init message, handle message, query message. So suppose let's look at how the init message schema looks like. Okay, so you'll see that in init message it requires a value of count on initialization. Okay, so now when you have the boson file generated and the schema generated, you know that the contract code you have written is working perfectly, is at least compiling correctly. If this step during polar compile there's any error, it's most likely that you have some issue in your Rust, compiler issue in your Rust code that you need to fix. And also, since these logs also contain the compiler logs, you will see that where exactly is the issue. So once you resolve those issues, once you have these boson and JSON files compiled, what you need to do next is, suppose you want to deploy your contract. And for the deploy step, this boson file can't be directly deployed to the network because this file is not optimized for size. So you need to optimize this for the size, so that the size of, so let's see like what's the current size of this boson file is. So it's showing that it's around 130 KB. We can reduce this size to further less by using the compression Docker images that has been provided by the Cosmosm. So next step, let's say you want to deploy your contract, initialize it and interact with it. For that you can use some scripts. We have a sample script in our scripts directory called samplescript.js. If you look at it, you see that you have first, okay, let me go through it. So first you import the secret polar library, you import contract class and get account by name method. So get account by name, what it does is that it reads your polar config file, and whatever name of account you have provided, since in this case we have provided account 0, it will fetch the account 0 details such as address and mnemonic and fill here. And so next you will see that there is a new contract object created for the contract name sample project. So you need to make sure that the boson file does exist for the sample project, and JSON schema files do also exist for the same name. It could be that you misspell the name here, or you haven't done polar compile before this step. If any of these things are not there, this line will throw an error. So make sure that these two things are correct. So contract.parse schema, it parses all those schema files that I just showed you and fills them into the contract object. So let's say you want to see what are the query methods for the contract and what are the execution methods for the contract. You can print them simply by using contract.txt. So contract.txt will print all the execution methods you can call, and contract.query will print all the query methods you can call. Okay, so in the next step in this line, we do contract.deploy, which deploys your contract using the contract owner address, which in this case is account 0. And if this account has some, so this account also needs to have some amount of native tokens to be able to deploy to the network. So suppose you are deploying to the testnet, make sure that you have got some native tokens from the faucet. And if that is not the case, it will throw an error and the error will be logged. So once it is deployed, it needs to be instantiated with some value. In our case, the value only required is count. So let's say we initialize with count 102, and the second argument here is the deploy test. So since this contract is a sample contract, many of us might have already deployed it. So if the same contract is deployed again and initialized with the same label, it throws an error. So we need to have a label which has not been used before. So let me just add something here. And the third argument is the account which will use to instantiate. So next step is executes a transaction called increment. So increment transaction in our contract increments the count value to +1. So here the count value should be 103, and the next one we query the count. So if everything works fine, at the end of this script we should see count value is 103. Okay, so how do we run this script? Is simple: polar run, then path of the script. Okay. So this tab I required because I haven't installed through Yarn, but I'm using a local development build, so you actually don't need to use this tab. Okay. So what this error is basically it's telling that the network you're using does not have proper config. So by default, whenever you run a command, the network that is used is the default network, which you can see in this config file. The default network only has one endpoint. So we'll be using the testnet in this case. To specify the network as testnet, just simply write -- network and the name of network in the config. So in the config we have the network name as testnet. You simply do that and it should work. So now the first step it will do is that it will call the compression Docker image, and it will create a compressed wasm file from it. So once that compressed file is created, that wasm file would be used to actually create the contract instance and deploy it and do further steps. Okay, so now you'll see that it has created the compressed file here, and the second step it has created the signing client for the network which will use to deploy and instantiate. So once the deploy is done, this response is sent, which includes the code ID, contract hash, and the deployment timestamps. If you are able to receive this, that means that deployment worked fine. And the next step, if this response is received which has the contract address, so if you get the contract address, that means the instantiation step was also successful. So and in the next step you'll see that this address is called and increment method is called. So this has also given OK response. So if this one has given OK response, then count should be 103, and when we query get count using the get count method, we see that count is 103. So that means the overall script ran perfectly fine. Okay, so this was just a sample script to give you a gist of how you can do certain things with a Polar run script. You can write your own scripts to maybe deploy multiple contracts, do interactions with them, and to check some values, or to do whatever you like. So if you see what other commands we have, you'll see that you have the node info. So node info basically gives you the information or the current status of any node. So let's say we want to see what's the status of the testnet. We can simply write polar node info and provide the network with again -- network testnet. Okay, node info. Okay, so this is given me the block height, which is the current block height of the network, and other metadata related to it. And other tasks we have the polar clean command. So what polar clean does is that, let's say you have created your artifacts in this directory and you want to start again, right? You want to clear all your artifacts. You can simply do that using polar clean. So the artifacts directory is gone now. And suppose you have there's a case where you have multiple contracts, so there must be multiple artifacts in the artifacts directory. You don't want to delete all of them. You only want to delete some of them for, let's say, a particular contract. So you can do polar clean and the name of the contract. Let's say the contract name is contract hello. Suppose this is the name. You can just simply do this. It will remove only the artifacts of that contract and not of the other contracts. And next we have polar REPL. So REPL is basically that is an interface where you can interactively interact with the network So the same commands you just saw in the script, you can do them here, just in an interactive way. And so you need basically two objects to interact with them, other than your contract related values, which are the polar environment env, this, and the polar config using the config object. So three things are already loaded, which is first is the config object in the name of config variable, and the second is the polar environment, which is stored in env variable. And it already has polar imported, so you can just simply write, let's say you want to create a contract object. You can say new contract. Simply you'll provide sample project and then the environment. Okay, so we have deleted the artifact. We need to create them again. Okay, it should work now. Yep. Okay, so let's see, we want to see what are the transactions available for it. So you can do that contract.tx. Okay, this one shows blank because you just haven't yet passed the schema. To pass the schema, you can do this. Okay, so now it should show. Okay, so it's showing that you can do two kind of execute methods. One is increment, and other is reset. Suppose you want to see what are all the query methods available, you can do that simply using this. And other same commands that you just saw in the script, you can do them here also. And yeah, those were all the commands that you can use through Polar. If you get stuck anywhere, you can approach us and you can open an issue in the GitHub repository of Polar.